All right, here's one more example. And again, chose this one because we want to add in a little something else that you're going to have to think about when you're doing elimination. All right, so take a look at the system I've got here. Once again, we go through our checks. First off, does everything line up? X's, Y's, the equal signs, the numbers, all seems good to go. All right, so definitely here we can do the process of elimination. Now, the second thing we look for is for what matches. But I'm hoping you're noticing, and again, this is why I picked the problem, nothing here matches. The X's, I've got 3X and 6X. I needed those to be the same. I've got 1Y and 3Y. And I need at least one of these sets of variables to match up. Doesn't matter that if these were to match up or not. What I care about is the variables, because that's what I'm trying to eliminate. So here we're stuck. So you might think, well, maybe I better do substitution. But we can still do elimination, because here's the trick. We have a tool that we use quite often from chapter 1. What I do to one side of the equation is fine as long as I do it to the other side of the equation. So as long as I do it to both sides, it's fine. So we're going to use that to our advantage. And what I want to be thinking about is that since everything lined up but didn't match up, what could I do to one of these equations so that something would match up? Okay, for example, I might focus on the x's. Here I've got 3x, here I've got 6x. So what could I do to both sides of this equation so that this would turn into 6x? All right, so there's a few things you could do, but the one we want to focus on deals with multiplication. We want to be thinking about what can I multiply this side of the equation by and then do it to the other side so that this 3x will become a 6x. Well, the answer is 2. So in fact, that's what I'm going to do. So I'm going to take this equation, I'm going to multiply the left side by 2, and what I do to one side of the equation, I'm going to do it to the other. That'll keep my equation balanced and still give the same answer. So I think the way you should show your work here is just to move across and rewrite this new equation. So 2 times 3x is 6x, 2 times y is 2y, and 2 times 11 is 22. All right, and if I recopy the bottom equation here, now not only does everything line up, these match. And now I can do it like the other problems. Now, if I go back, and in fact, you know what I'm going to do is I'm going to write this, I'm going to rewrite this down here. If you choose to include this in your notes, I might put it maybe to the side because this is an incomplete example that we're going to do. So let's go back to the original problem. Let's say instead someone had chosen to get the y's to match up. So think to yourself, what would you have done here? Similar move to this one, but let's say they decided they wanted the y variable to match up and not x. What could you do? Well, hopefully what you're thinking is something very similar. We would take the top equation, but to make this y match up with this 3y, we'd multiply this equation by 3, as long as what I do to one side, I do it to the other. And so here we'd get this. So once again, this is one of those things where if you understand it, great, but you have to understand it well enough to make decisions when you could do it a couple different ways. So I could have done it this way. I could have multiplied the top equation by 3, which would make the y's match up, in which case the next move would be to subtract, and these would disappear. All right. Or I could do it the original way, which this is the one we're going to follow through with. I could multiply the top equation by 2, which gets the x's to match up. Then I need to make my decision, add or subtract. Well, once again, your decision is, what can I do to these matching items so that they are eliminated from the problem? Do I add them? In this case, I don't think so. 6x plus 6x is 12x. We want them to disappear. So the decision is to put a big giant minus sign over here, because that way 6x minus 6x disappears. Again, think of these pluses as positives. Positive 2y minus positive 3y would be negative 1y. And again, even on the right side, go back to this minus sign. That's why we write it nice and big over here. 22 minus 24 is negative 2. Solve this equation for y. Divide by negative 1. So y equals positive 2. And once again, we're halfway there. So part of my answer is something 2. All right, but that's the big one. This idea up here that in the beginning we had things that lined up but didn't match up, so we used multiplication to make something match up. Okay, we have to do this sometimes to tweak the system so that it works with this process. All right, multiplying either the top or bottom equation by something so that parts of your equation match up, like our 6x and 6x here. All right, but the rest of this from this point on is straightforward as before. This becomes our substitution. So it's telling us to go back to one of the original equations and plug it in to figure out x. As always, you can pick either one of the originals, so I'm going to pick the top one, again, just because it's got slightly smaller numbers. 3x plus, swap out y, equals 11. Okay, notice I'm not incorporating the 2, I'm just using the original equation, not the modified version. Alright, and I'm going to swap in y is 2. Alright, and then I'm going to solve that equation. X times 3 plus 2, first move would be to subtract 2 from both sides. 3x equals 9. Divide by 3, x equals 3. Alright, so the supposed solution to my system is 3, 2. Finally, check things. A lot of steps, a lot of different moves here. We got to check we did it right. Alright, so I'm just going to take this top equation. Let's just keep using blue. 3x plus y equals 11. X is 3, y is 2. 3 times 3 is 9 plus 2. 9 plus 2 is 11, so that one checks out. Alright, let's take this bottom equation. Let's do it in red. 6x plus 3y equals 24. Let's plug in our answers. X is 3, y is 2. And see, 6 times 3 is 18. 18 plus 3 times 2 is 6. 18 plus 6 is 24, which equals 24, so it checks out. Alright, so this is our solution to the system. But I think the one difference in this example is this idea that sometimes our equations might line up, but they don't match up. So to make them match up, we use multiplication. We say to ourselves, what can I multiply one equation or the other equation by to make something match up?